This video is part 2 of the polynomial long division for the extra practice, and we're going to do numbers 3 and number 4. So number 3, these two are different from the first two because now we are dividing by 3 terms instead of 2. Number 3 is written a little differently from the other ones, but when it's set up like a fraction, we just set up our long division the same way. This is what will go on the outside of our division to the left, and this will go on the inside for a quotient. So we have x squared 4x minus 2, and it will go into this expression. Again, we need placeholders if we're missing a term. Checking here, I have 4, 3, 2, 1, and a constant, so nothing's missing here, and I could just write it in as is. Okay, so for division, we look at the first term of both expressions, and off to the side, I'm going to divide the number that's inside our division, so 3x to the 4th, by the number out here, x squared. Okay, so you might see 3 terms and think, oh, this is going to take extra long, but actually 3 terms means it's going to be a little bit shorter for our division, because if we notice here, when we divide, this will come out to be 3x squared. So actually, I'm going to be starting closer to the end here. 3x squared is my first term here, so 3x squared. Okay, so when we do to find our number up top, we have to next multiply it to what we're dividing by. So this will be 3x squared times this x squared plus 4x minus 2. So when I distribute, I will get 3x to the 4th plus 12x to the 3rd. So remember, we're adding exponents when we multiply and multiplying the number in front. So 3 times 4 is 12, x squared, and x gives us x to the 3rd. 3x squared times negative 2 is minus 6x squared. And then we subtract. So I'm going to subtract all 3 of these. First term should always cancel, which they do. 15 minus 12 is 3, x to the 3rd. 3 minus negative 6, so a double negative becomes a plus. So 3 plus 6 is 9. And then we bring down our next term. So I'm dividing by 3 terms, and I'm making sure I keep 3 terms here when I do the division. Okay, so we just keep repeating this process. So now I have 3x to the 3rd, and off to the side here, I'm going to do 3x to the 3rd divided by x squared, and that will leave us with 3x. Okay, so 3x is our next number, plus 3x. So don't forget, we need our plus and minuses when we rewrite it up here. Okay, and now I'm going to do 3x times what's out here. So 3x times x squared plus 4x minus 2. So 3x times x squared will become 3x to the 3rd. 3 times 4 is 12x squared. And 3 times negative 2 is minus 6x. So it's similar to what we ended up here too. So now we subtract. Subtract, subtract, subtract. First terms cancel. 9 minus 12 is negative 3x squared. And then negative 12 minus negative 6, it's like addition, so this will be minus 6x, and bring down the last term, plus 4. So now I have 3x squared, negative 3x squared. I'm going to write it over here, negative 3x squared, and divide it by x squared. Here the x squares will cancel now, and I just have negative 3. So that will go up top, minus 3. And then we have to multiply. So I have 3 times this x squared plus 4x minus 2. Oh, sorry, negative 3. So this will be negative 3x squared minus 12x plus 6. And then we subtract. So negative 3x, this will cancel. Negative 6 minus negative 12 becomes a positive 6x. 4 minus 6 is negative 2. So if I go off to the side, I'm left with 6x. If I went off this to the side and do 6x divided by my first term, well, now this exponent is bigger than the one I have up top. So I know that I'm done because this should always divide into what we have above, like before the denominator would cancel out. But not just the denominator, but the x value in the denominator cancels out. So since this would end up to be 6 over x, this can't be one of our terms. So that's how we know we're done. So as soon as this exponent of our x value is smaller than what we're dividing by, then we know we're done. So this is my remainder, this 6x minus 2. So this will be plus my remainder of 6x minus 2 over what I divided by x squared plus 4x minus 2. And there is that answer. So not quite as long as the first two because we have more terms. So we're going to do one more here, number 4. Okay, so I have x squared plus 4x minus 1, and I'm dividing that into here. So do we need placeholders? I have 4, then 2. So yes, we are missing x to the third as a placeholder. Okay, so I'll have x to the fourth and 0 x to the third. So 4, 3, 2 minus 17x squared plus 4x minus 1. So looking at our exponents, I have 4, 3, 2, 1 constant. So we're good. Okay, so we look at the first term. And off to the side, we divide. So I do x to the fourth divided by x squared. And subtraction rule for exponents, we're left with x squared. So here's my first term of x squared. And I'll write it above the x squared in the division. Okay, so I'm going to multiply this by what I'm dividing by. This is x squared plus 4x minus 1. When we distribute, you add the exponents, so this will be x to the fourth. This will be 4x to the third, and then minus x squared. And then we subtract. Subtract. So this will always cancel. 0 minus 4 is a negative 4. Negative 17 minus negative 1, so it becomes like a plus 1 to get negative 16x squared, and we bring down the next term. So making sure I maintain 3 terms here because I'm dividing by 3 terms. Okay, so we look at our first term and divide it off to the side here. So this is negative 4x to the third divided by x squared. Subtraction rule, we're left with negative 4x. So that will be my next term up top. So this is minus 4x. And then I'm going to multiply this by what's on the outside. So 4x times x squared plus 4x minus 1. When we distribute, we add the exponents. So this will be, I keep creating those negatives. So this is negative 4. So this will be negative 4x to the third minus 16x squared plus 4x. Well, look what's happening here. When we go to subtract, Negative 4 minus negative, so 4 plus 4, that cancels. Negative minus negative 16, that's negative plus a 16, that cancels. 4 minus 4, that's a 0. Everything cancels. We have no remainder. So this will be our final answer. Okay, so when we have no remainder, something divides into it and we don't need that fraction, that means that this expression is a factor of this original, of this first expression.